Hello and welcome to the Ashesi Gardeners Centralized Database. My name is Anakofijan and this is my final database project. This database was created to help the gardeners of Ashesi to work based on a strict schedule where their work for the day is allocated to them. It also helps to make sure products and equipment are not manhandled or misused. Last but not the least, based on the work each gardener has been allocated, their number of hours will be logged per day, and at the end of every 2 weeks they would receive their wages based on the number of hours they work. This will encourage them to work harder, faster and smarter in order to receive a higher wage. This database has 6 functionalities. The functionalities are: supervisors will be able to check the hours a regular gardener worked; inventory tracking, that is checking which equipment is low on stock. The supervisors will be able to check which gardeners used a gardening tool and display the time they used it. Now this functionality is only going to be for tasks that have been completed. Supervisors will be able to also check which gardeners have not completed their tasks and the task they must do, that is the work they must do. Gardeners will be able to view the tools needed for their work in their schedule and the times they would need it. And then lastly, supervisors will be able to view the information of the ordinary gardeners and their schedule between a certain time. To make sure these functionalities work, a foundation must be laid. That means a logical database must be created. Now, the logical database has been divided into 3 subsections, which are the strong entities, the weak entities, and then the normalization entities. The strong entities have 5 tables, which are the gardener's equipment, supplier, work, and area. The gardener's table would have its own primary key, which is the gardener ID. We'll have the gardener type as a foreign key, the first name, last name, date of birth of the gardener, and the phone number, which is going to be defined as a unique index, and lastly the gardener gender. The equipment table would have the equipment ID as a primary key, the equipment name, equipment type, the description of that equipment, and the serial number of the equipment. The supplier table would have the supplier ID as a primary key, the supplier name, the supplier contact number, and email. The work would follow the same format and have a work ID as a primary key, the work name, the work description, and the number of gardeners required. The last table for the strong entity, which is the area, would have the area ID as a primary key, the area name, area type as a foreign key, and the area size. The weak entities would include the schedule and the inventory. The schedule would have its own primary key, which is the schedule ID, and it would continue to take in the gardener ID as a foreign key, the equipment ID as a foreign key, and then the start time, completion time of each task, and the status of that task, whether the task is completed or not. The inventory table would also have its own primary key, which is the inventory ID, but will also have the equipment ID as a foreign key, the supplier ID as a foreign key, and the quantity of that equipment. The normalization entities would be the equipment category, the gardener category, and the area category. Now all of these follow the same format. They will each have their type ID as primary keys and their type name. Moving on from just the reading, our database must also be visualized. That is done using an EAR diagram. Now our EAR diagram states that a gardener can have 0 to many schedules, and a schedule is for exactly one gardener. A schedule is for exactly one work, and a work can be for many schedules. A schedule is for exactly one area, and an area can be for many schedules. A schedule needs exactly one equipment. A piece of equipment can be used by 1 to many schedules. The inventory has 1 to many equipment, but an equipment belongs to one inventory. A supplier can supply multiple items in the inventory, but an item in the inventory is supplied by exactly one supplier. Now lastly, we move on to creating the database. So I'm going to run the database. See, the first time, no errors. We run it again, no errors again. So my database, my first 3 creations of the tables were my normalization entities, which were the gardener category, the equipment category, and then the area category. Each of them have their primary keys, which is their type IDs, and then their type names. We're going to take varchar 20. I also created unique indexes on them. My first creation of strong entity was the gardeners table, and I stated my gardener ID as the primary key. I have my gardener type, which is a foreign key and on the delete cascade. I have my first name, last name, date of birth, phone number, and gender. Now, gender, I use a check for M or F. F means female and M means male. I create index on the gardener phone number because no two gardeners can have the same phone number. The second table I had was the equipment table, and in the equipment table I had my equipment ID as the primary key, and then the equipment type as the foreign key, also on delete cascade and update cascade. And with that, I also have the equipment, the name of the equipment, the serial number, and the description. The serial number I also used the serial number to make a unique index. Now, the second strong entity I made, the third strong entity I made was the suppliers table. Now, suppliers table also has its foreign key as a supplier ID, but has no foreign key because it stands alone. It's not dependent on any other table. So we have the supplier name, the supplier contact number, and the supplier contact email. I made the contact email for the supplier also a unique index. Fourth table I created for my strong entity was the work table. The work table also has its work ID as the primary key. Has the work name, the description, and then the number of gardeners required. The last strong entity we have was the area. In the area, we have the area ID, the area name, the area type, and the area size. The area ID is declared as the primary key, and the area type is also a foreign key and on delete cascade and update cascade. Now, I created a unique index on the area name. My first weak entity was the schedule. In the schedule, I had a list of foreign keys, a primary key, which is the schedule ID, and then 3 key attributes: the start, completion time, and then the status. Where the status takes the boolean 1 or 2, where 1 means completed, 2 means not completed. So I created the references for the foreign key and added the on delete and on update cascade, and I created initialized my primary key for the schedule ID. I did the same for the inventory, where I had my inventory ID as my primary key, and then the 2 foreign keys I have were the equipment ID and the supplier ID, which were also on delete and or update cascade. And then I had the quantity, the number of equipment in stock, and then I proceeded to populate my tables, and then we move on to the queries. For the queries, our first query says that supervisors will be able to view the information of the ordinary gardeners in their schedule between a certain time. So we're going to use time, the start time, as the certain time we're going to use. So the supervisor will be able to specify the time they want to look for, and check to see all gardeners that had a start time below the specified time. And the type is set to 2 because 2 is for ordinary gardeners. So if I run this query, I have 2 gardeners, Isaac Fojo and then Yaamwa, who were planting and hedge trimming, and their start times were below 8:40 because they had 8:15. The second query is gardeners will be able to view the tools needed for their work in the schedule and the times they would need it. I have the work name, equipment name, type name, equipment area name, the start time, and the completion time. Now, in doing so, I use an inner join. So I inner join the schedule where the gardener IDs of the schedule table is equal to the gardener ID of the gardener table, and then I look for, so you see, because it's gardeners will be able to view the tools needed for their work, we're going to use the name of the gardener, where I concatenated the first name and the last name. So for Isaac, the work he has to do is lawn mowing and planting, and the tools, the equipment he needs is the lawn mower and the soil knife, and the start time and completion time of each work in the area and the equipment type name he uses. The third query is supervisors will be able to view which gardeners have not completed their work and the work they had to do. So this is going to look for where the status is equal to 2. Now the status being equal to 2 means that the work has not been completed. So we're going to search for all gardeners who have not completed their work and the work they have to do. So if I run that, we're going to see that Isaac Fojo, Lizzie Asante, Yusuf Mohammed, Yamwa, and Moses Viabeto have work they have not completed yet, and they're going to show the areas they have to work at, the start time, the completion time they have to abide by, the work name they have to do, and their phone numbers to contact them to get their work done. Fourth query says that supervisors will be able to view the gardeners that last use an equipment. This is only for completed tasks. so which equipment you want to look for, and then the status has to be 1, because if you complete the task, we need to know where the equipment has been put, or we need to contact you for the equipment so that we can place it back in the inventory. So it's only for completed tasks. So if I run this, we're looking for all equipment that start with hedge. So if I run this, we see that okay, our work name is hedge trimmer, the equipment's name is hedge trimmer, and the time it was used was this, and the full name, the person who used it was Yusuf Mohammed. It's his phone number, so we can easily contact him to let us know when he can bring the hedge trimmer. Now move on to our 5th query. Supervisors will be able to track inventory by checking the quantity of each equipment and which supplier to contact for more if the quantity is below 7. Now we made the assumption that if the quantity is below 7, then the equipment is low on stock. So I created a sub table where I selected all from the inventory and labeled that table as sub. I set my quantity to where it is below 7, and then I just picked the relevant information and I ordered it by the quantity, so the lowest quantity comes first. So as you can see, the lowest quantity comes first, and the supplier name for each equipment is there, and the equipment serial number too as well. The last query we have is supervisor will be able to check the hours a regular gardener worked. Now this check is only for the hours worked in the day. So I use the completion time and then the start time and divided that by 10,000, because we had a large integer when I subtracted the start and complete times, and then I proceeded to sum the hours worked and group them by the gardener ID. I use an inner join and an in facility where that's how I checked for only regular gardeners. So if I run this query, we see that all our 5 gardeners have logged their times work for the day. Thank you, and this is my database project.